So basically, just open document. So basically, let's start with the height of a tree. Height of a tree. How it is defined and how we can calculate it. Let's try to understand it. See, let's say we were given a tree. This,
Yep.
this, 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 and okay. I need to calculate the height of the tree. Height of the tree is the maximum, you can say, this the depth of last leaf node, basically, you can say, like from root, you can see that. Okay, there you can see the level also, the last level. Basically, you can say a level 1, you can say this is a level 2, this is, you can say, the level 3, and this is, you can say, the level 4. So you
Okay.
can say that the height of the tree is 4 equals to 4. Now, we need to calculate it. How we can calculate it? We have to understand it. Okay. Uh, like there is one way. What is one way? Like we can calculate the l- maximum level. There are two ways. Let's try to understand how we can calculate it. First, using level order traversal. Order traversal, and one using recursion. Using level order traversal, it's more easier to understand. Easier to understand.
Mm-hmm.
But just the code is lengthy. Just a code is lengthy. How? See, when we have wrote the level order traversal, if you remember, if you know the level order traversal code, it's like it's a simple cakewalk. What you need to do is just you need the change in the level order traversal code. You just need to traverse and you just keep a maxi variable of the levels at what maximum level we are going. So whenever you are reaching a new level, you just update the maximum. Maxi is equals to max of maxi comma level,
Okay.
and we can just return that level, return this maxi. Simple. We can just figure out, okay, and this is our height because we know that because we already know that how to keep track. So just go to the maybe the last class. Just check if I have. Yeah, yeah, I have. So if I go to that level order, show files, pre-order, in order, yes, level order. Maybe level order is in our here, the data build. Okay, I think it is in our VS Code. Let me just go to VS Code. Just a second. So basically, let me just copy the level and go to this one. Go. Yeah, basically, if you can see through it, we are writing a level loader code. So basically, what we have to do here, we can here we start a new level, right? So from here,
Yep.
our new level starts. So whatever you can do, just either you can maintain a level variable, you can say int level is equals to
Okay.
you can say 0, and you can just increment whenever you reach here a level plus plus.
Okay. Okay.
Whenever, so how many times this here we will reach? the level number of times. Suppose there this is a 3, so the level becomes 1, 2, and 3. So at the end, when this loop ends, and when we reaches here, the queue becomes empty. The value of the level will be 3, 3, and it will be easier for us. So, like, it's very simple, but just you need to write this level order code for this if you want to calculate the height of the tree without help, without recursion. This is one way. The other way is,
Yeah.
I can say, let me just write it. This is one way, one way you can level order, because it's very easy when you understand this code, right? Level order. This is very simple. Okay, this is because you don't have to write the recursion here. You are using, so it's more intuitive. Okay, you can understand. Just the code is slightly bigger than the recursion code. There's that obviously always a trade-off between the length of the code and the understanding. So yeah, let's try to understand how we can do with the help of recursion, which most of the people, and I think in your notes also said that. Yeah, let's try to do with the help of recursion. So let's try to understand how we can do that. See, we are here. If you're talking about this tree, now let's try to understand. Okay, I will ask this guy. Like, I want to calculate the height. This is the root. Okay, I want to know the height of this complete tree. Okay, so I will ask him. Oh, can you tell me the height of the tree? So he will say, yeah, sure. I can. He tells me a relation. The
Okay.
height of the tree is equals to whatever is the height in the left of mine, and what
Okay.
maybe in the right of mine, and include me as well, please, because we have to include this also, right? If you go to this left or right side, because there is one level of him also. So he told, oh, you please go and ask my left child about the height of the tree, and maybe the right child of the height of the, and take the maximum of both of them and add one to it, because one due to himself. Okay, cool. Then he will go and ask his left. He asks his left one. So left will say, "Oh, uh, I have no left child and right child." His left side will say, "Oh, I don't have anything." So they return a zero to him, and the right also return zero to him because they don't have any heights. The left child say, "Whenever we get a null, obviously the height is zero only, right?
Yep.
Height is zero." So basically, the height is zero. Okay. So he know his height. Now he know his height. His height would be 1 plus maximum of left comma right. We already know these answers 0, 0. So his height would be 1. So he would be returning. He will be saying, oh, left height of for this
Yeah.
would be 1. Okay, cool. Then he will ask right about it. Can you tell me your height? Okay, right will say, okay. So right will say, my height will be 1 plus whatever my left and my right. Okay. So his height is not directly computed. Here it is computed directly because you can say these are the base cases because they are null nodes. Here they are not null nodes. We need to again calculate. This is a recursion. So we will go and again say max of left comma right. Okay, fine. Left comma right.
Okay.
Then he will go and ask him, oh, do you know your height? So he will say, yeah, sure. Let me just go again and tell you from here, what is my height? So he will say, now he will ask him. So he will say, yeah, I know my height. My height is 1. So he will say 1 to him. Okay. Then he know, okay, yeah, I know my height. My left is 1 and my right is 0. So he will say maximum of 1 plus maximum of left comma right. So he will say 2 to him. Okay, my height is 2. And then what he will say? He will say, oh, nothing on my left side, nothing on my right side. I don't have anything, only myself. So he will say 1. Now he will
No.
uh,
Okay.
now he will say, oh, my left is giving me two and my right is giving me one. I will take maximum of both of them plus one myself. So he will return three. Okay. Now,
Yep.
now root got his from his right also and from left also. Okay. One or three. Your maximum will be three only. I will taking three only. So max of left comma right plus one. So answer will be four. This is how the recursion calculator. This is important. This is our recurrence relation. Recurrence relation. You will be asking how I got it. You can say this is not much intuitive, but yeah, like if you can understand this, how we write this, yeah, this is
Mm-hmm.
the beauty of recursion, right? Like when you write some
Yeah.
code, you will understand how to write recurrences. This time
Uh,
I wrote it, try to understand it, grasp it, okay, how it's working. Then maybe after some practice questions, you will be able to write yourself the recurrence. And
No.
this
Okay.
is the
Okay.
recurrence. And I told you the null height is zero. This is our base case. I already told you. Whenever you find a recurrence question, try to find the base case. Try to write
Okay.
the recurrence relation, and then call. Okay. So basically, this is our base case, and then call the recurrence. Or you can say call recurrence. Yeah, that means call for your shorter nodes. We can say left node and right, and maybe recursion calls. Recursion calls. This is our idea. Let's try to write the code for it. Now, if we understood the base case, know the recurrence relation, so it's very simple for us to write. So yeah, let's
Yeah.
try to write the code for it. Hmm, height of the tree, height on the tree. So basically, uh, we will be obviously we will be returning int. So basically, the return type should be int. Height is an integer. So here we can say height, and what we'll be taking again for all tree problems. You just need the root of the tree. You can say node star root. Yeah. So basically, you got int height node star root. Fine. So firstly, what you will write base case. So you will write the base case. If root is equals to null, I already know his height. No need to calculate it. I know it is zero. Please return zero. Okay. That means his height is zero. Fine. That's great. Now, when I'm here, okay.
Yep.
So I will ask whenever I'm saying go and ask the left and right, this root will say, go ask my left and right their heights, and then I will do something. So here we write the uh, recalls. Ask the left height. How will we do that? No problem. Recursion will solve it. Height root dot left. Root. It's not our job. It's recursion job to bring me the height of the left and right. Right.
Yep.
Right. And then we write root. Right. Fine. Once we have the left and right, now I know what height will be. I know that height would be 1 for the root plus maximum of left comma right. Left comma right. And now it's straightforward. Just need to return. Just return
Okay.
this answer. This is the height. This is a simple code of using recursion. This is more, we can say you are not using any additional queue as well. So you're saving space as well. This code is good. This code is shorter. But yeah, from how we read here is very important. How we wrote the code for it, how we wrote the base case, how we wrote the reconciliation, how we got the idea. Let's try to set in the code as well. Okay. Yeah. So let
Yep.
me just show you. Hmm. Just copy this one. Very, very neat. Hmm. So you got it. Hmm. Got the data and so then let's try to write int 5. Okay, just make free. So basically we just need a node star root, root. Then firstly we will write the base case. So yeah, we just write the base case and then we will say if root equals to null, then we will just return a 0. We know the height, it is 0. Fine. Now we will call the recurrence. Please tell me the left height. Left height is equals to, it's the complete left subtree height. Okay. For this, he will call.
Yep.
Okay, he will see. Okay, what is the left subtree height? Then he will call it height, and just we need to pass because now my new root becomes root dot left. Then similarly call right height is equals to height and root dot right. Okay, fine. Now if I have both the things, we can calculate the height, actual height of the tree. You can say max of left height, left height, comma, right height plus one for the root node, and then we can just return it. Yeah, let's try to see if it is working fine. So let me just calculate the f for the root, and let's try to all the built-in function as well. Node star root is equals to new, not new, it's called a built-in function. Build tree. Oh, yeah, let's try to see that. Let's try to make a small tree. Okay, what happened? Oh, okay, maybe what happened? H is undefined. Oh, sorry, it's high. Yeah, let's try to call it. So let's try to make this tree. Let me just name the
Okay.
nodes. It is 1, it is 2, it is 3, it is 4, and it is 5. Height should be 3. So yeah, let's try to understand it. 1, 2, 3, 4, 5. Yeah. So one has two child, 1, and the left child of 1 would be 2. What would be the left child of this? No one. What is the right child of 2? I don't think so. Anyone is of left child 2? No. No one is there. Right of 3, it's 3. Uh, left of 3, it's 4. Left of no one. Right of 4 is no one. Right of 3 is 5. No one. No one. Yeah. So 3 it gives. Right? It gave me the height of the tree as 3. So here the levels are, you can say this, say 1, 2, and 3. So this is how we calculate the height of the tree. So any doubts still here?
No.
It's fine. Yeah. So
Yeah.
more or less, yeah, this was the height of the tree. You can calculate from this. There's this as well. Just you need to, let's try to write the code for this also. No changes in the code. Just we need to copy the level order code from here. So this is the level order code. Level order.
you can just keep a, maybe you can say level counter level is equals to 0. And whenever a new level comes, you just do a level plus plus level
Okay.
plus. And just we need to return this level. No need to change in the level order. Return level. Let's try to see this as well if it is working with. Oh, I haven't created int. Yeah. So this is called. Let me just call the level order, and proof. Hmm. So yeah, let's just call it. Can make the same tree. One, what is left of one, two, nothing in left of two, nothing. Right of two, right of three is three, left is four, left of no one, right of no one, five, no one, no one.
Yep.
Oh, okay, yeah, he gave the three, right? He gave the return
Yes.
value three, and this also three, and he just printed the three also. One, two, three, four, five. So